Thanks, Adrian. I can, in fact, spell, so thanks for the title. I have no spiritual insights, and as an engineer, I've got no feelings either. So the only useful role I can play here is to do some adding up, and that's a familiar role. I've been doing adding up with the IPCC, with the International Energy Agency, the UK government, Extinction Rebellion, schools, pension funds, mining companies, etc. So it's great to be here, and the question is always the same. If we all do a little, we get a little. So what does real zero emissions actually mean? This is the first time I've had the chance to talk in the church context. I'm really honoured to be here, and as Adrian kindly invited me to do this more than a year ago, I've had two students, Annabelle York and Charlie Friend, have done their final year dissertation to help me get ready for this, and I've had a lot of support from Tobit Curtis, who is a professional in historic building conservation in Cambridge. A year and a month ago, Adrian invited me to give a 45-minute talk, and 5 seconds ago he asked me to cut it to 35 minutes, which is the form of welcome you get only in the north. To summarize, in case he cuts me off even quicker, in case he cuts me off even faster, to summarize, I want to say 4 things. Firstly, the government's current plans are not going to deliver zero emissions, and that's because they all depend on 3 resources, and we don't have enough, and we won't have enough of them. It's important to understand that. I think it's very unlikely that the church will deliver on its net zero pledge by 2030, and I think we should face that and think about the consequences. The 2 hardest things to do in cathedrals are to keep warm and to avoid using any cement. So I'm going to talk about the solutions to both of those. And then I want to propose a more achievable plan for what I think you could do in repledging and demonstrating a real leadership role. We've all said this, there's no business as normal. I don't think anybody's nailed it yet, though. Sea level rise, temperature rise, they actually sound like going on holiday, don't they? We don't have to go to Spain to lie on a beach and drink cheap beer and eat horrible sausages next to other people. We could do it in the UK. So I had a PhD student who finished this January who had the exotic title of How Will Society Collapse If We Fail to Mitigate Climate Change? She was a very, very good student and has gone on to a more happy job elsewhere. The answer is, unfortunately, that we're going to starve. Climate change is about food. We're going to get a foretaste of that this year with the wheat shortage. We're going to get a much bigger hit next year because 70% of the world's fertilizer is made in Ukraine and Belarus, and we're not going to be able to access it. So yields next year will be lower. But that's peanuts compared to what's coming. The microphone's here, and I've got no pointer. So I thought maybe I could point by saying that graph there is a plot of crop yields in all the countries of the world over the last 50 years. And the green curves fitted to it show that the crop yield in a country depends on the average temperature in the country. If it's too cold, you don't get very much. If it's too hot, you don't get very much. But since 1960, we've been really good at technology. We've got better at getting more plants out of the ground. So the green curves demonstrate better agricultural technology. But you can see that what's happening now is as we get warmer, we're moving to the right on all those curves, and the rate at which temperature rise is decreasing yields is now beating the improvements in technology. The red line is for Pakistan, and that story, sadly, is going to play out in the equator. So the graph on the left is the number of people at risk of starvation this century around the equator, and we anticipate that 1 billion people will starve to death if we don't act on climate change. Either that or they'll migrate north and we won't be able to accommodate that without a war. So that's actually the issue. It's not sea level rise and a bit of wind. It's 1 billion people starving to death. So we better do something about that. We have a lot of policy, but before we start thinking about what might be real policy, let's just knock on the head the red herrings. Bill Gates says that he continues to use his private aeroplane because he's paying for negative emission technologies to take the emissions out of the atmosphere. Well, what rubbish. It takes a lot of electricity to power a big fan to take emissions out of the atmosphere, but you got you got much less energy when you release the emissions into the atmosphere. So if you've got spare renewables to power negative emissions technologies, for goodness sake, don't use them for that. Use them to replace coal and gas-fired generation elsewhere. It's a completely vanity project to have negative emissions technologies powered by renewables. This is tough for you given what we've just heard about your own plans, but there are no offsets. Think about it. If you book a flight now, then you are increasing the stock of emissions in the atmosphere. The only mechanism we currently have to get them out there is to plant a tree, but right from childhood, you've counted the rings on a tree to look at how long it takes to grow. In the first 20 years of its life, a tree doesn't grow very much because it's a sapling. It's only when it's got its full canopy that it starts to take the emissions out of the atmosphere. So if your pledge is net zero by a certain date, the tree has to have reached maturity by that time, and there isn't time left. There are no physical offsets, and a financial mechanism is just burden shifting. So forget offsets. Geoengineering, the bizarre idea that we should not deal with it and then we'll put particles into the sky to create more clouds to protect us from the sunshine. Have we ever had an intervention in the ecosystem without unforeseen consequences? Never. And there is no way that we could survive doing that without something even worse happening. Population growth, if you give a talk to right-wing audiences, somebody always says, but we should stop people having babies. Well, actually, the people having most babies are very poor people, and they don't emit very much. The people who are causing most emissions are Americans. So if you want to reduce the population, focus exclusively on reducing the population in America, and I'm not quite sure whether birth control is the most efficient means. And waiting and responding at the time, there isn't time because we're going to be short of food. There won't be time to adjust and create a new organic agriculture in the amount of time we have from once we are really frightened. Unfortunately, it's very difficult to get to adding up the numbers in a simple way in this area because there is so much greenwash, there are so many vested interests. And the one that I fight is the innovation, venturing, business as normal economic growth driven by invention, conspiracy theory. My own colleagues in universities get more funding if they say they've invented something to do with climate change. Venture capitalists and banks want to fund it. Companies want to grow by accommodating it. Governments want to support it by policy that says, don't worry, we're going to get richer by dealing with the solution. That is the biggest greenwash that we all have to fight against. There are lots of things that could have a small effect, but the problem isn't getting something to happen once. It's the big scale of changing the way that we all do something within 28 years. So let's have a little bit of a look at climate policy. There are 5 sectors there of global emissions. I made it simple because I know some of you aren't engineers, and I've taken the numbers off. Transport, heating, appliances, industry, and agriculture are the drivers of all the world's emissions. And current policy, the only policy portfolio discussed at the entire COP26 meeting and in current discussions in the government and in the United Nations, are that we should deal with transport through electric batteries, hydrogen and biofuel, electrify heating and appliances, industry by hydrogen, electricity or carbon capture and storage, and agriculture by negative emissions technologies like the nonsense that Bill Gates is talking about because nobody wants to face up to changing agriculture. Well, we need to be rather careful about that. Have we got the resources to deliver on that? If you'll excuse me, a slightly engineering-oriented diagram. Our demand for goods and services, whatever it is that we buy when we spend our money, is serviced by, let's call them processes, which depend on fuel. If they use fossil fuel, then they have to be linked to negative emissions technologies. If not, if they use a synthetic fuel, we've got to make the fuel. Either we make it from fossil fuels or we use electricity to make it, for example, hydrogen. If the electricity comes from fossil fuels, then we need to capture the emissions and put them through a negative emissions process, or it comes from renewables or nuclear. And what that means is that every single mitigation plan in the world depends on 3 resources only, and those are biomass, non-emitting electricity, and carbon storage. There are no other resources available to resource our plans for a zero emissions future. So let's think about how much of that we need. I've got a graph here. I'm sorry for that if you're not used to graphs. We like them. On the x-axis is carbon capture and storage in megatons per year, and the y-axis is non-emitting electricity generation. We've done a set of calculations on all the plans put together at COP26, the corporate plans, the economists' plans, those that are discussed in the UK government, and made an estimate of how much carbon capture and storage and how much non-emitting electricity you need. There are many estimates because, of course, the steel industry could carry on with carbon capture, or it could use electric hydrogen in order to do things a different way. So we've added up lots of different versions of the plan, and in total, that egg represents the space being discussed in policy at the moment. Where we are is on the red dashed lines. This is the amount of non-emitting electricity we currently have available in the world, and the total world installation of carbon capture and storage hasn't even left the axis yet. Oh, don't worry, say the economists, all you've got to do is to get the price right, and then things will grow. They forget that the main speed restriction on building nuclear power stations isn't the price. There's a degree of public consultation. It's a rather complicated project. It takes ages. Hinkley Point C will have taken 22 years from the political commitment to when it operates, if it operates on time, but we can't really predict that that's going to happen given the experience with Crossrail. So by the end of this decade, we will know how many nuclear power stations will be in the UK by 2050. Perhaps one, perhaps two more than we have now. There isn't time to build more. So let's just look at the three resources. On the left is powered carbon storage in the UK. For those of you without a numeric degree, the line at the bottom is straight and has a value of 0. And if we forecast where's that going to be in the future, it's going to continue being 0. We have no carbon capture and storage in the UK. On the middle one, the smallest use of oil in the world is for kerosene by volume. If we were to replace all kerosene used in aeroplanes with biokerosene, we would need the red line worth of biomass. The green line is all the biomass that we currently use for food in the world. In other words, to replace just kerosene with biokerosene, we need to treble the harvest of all food production in the world. It isn't going to happen. Biomass is not going to be a significant contributor to a low-carbon future. On the right, energy in the UK, the blue line is how much electricity we'd need if we electrify everything. The orange line is how much non-emitting electricity we're generating. We've grown it well in the last decade. It's grown in a straight line that you can see. No, I can't get it. The straight line in the middle there. I've now run out of pointers because all the rest have got water in. We aren't going to have enough non-emitting electricity. If we look globally, the story is the same. I'll show you that. I've given the slides to the organizers, and you can download and borrow them and send me an email if you want to know more. Realistically, if I'm ambitious at the rate at which we grow non-emitting electricity, it's going to get into this purple band. If I'm ambitious about how much we're going to grow carbon capture and storage, it still won't leave the axis. So a sensible position for thinking, well, sorry, before I say that, all current policy, therefore, is outside the feasible bounds of the resources that we're going to have available. And this wasn't discussed anywhere at COP26. The largest delegation was the oil and gas industry. Nobody at all stood in that room and said we haven't got the resources to deliver on it. What might be real? Well, we think might be real is here. A sensible forecast of non-emitting electricity, no carbon capture and storage. And we used that basis to write a report called Absolute Zero in 2019, which has had more impact than anything we've done. It was debated in the House of Lords in 2020. You can download it there if you're interested, or find the slides to find the link. And it's now the second most downloaded document ever from the University of Cambridge, second to Stephen Hawking's PhD thesis, but we're about to overtake him. What it describes is a realistic view of getting to zero emissions with the resources that we actually will have available, rather than pretending that all of these magic beans fertilized by unicorn's blood are going to drop onto the ground. They aren't. So, to translate that back onto my pie chart of emissions, what a real solution space for zero emissions by 2050 means is closing anything that causes emissions by its chemistry, which primarily is cement production, cows, and sheep. They all have to close because there are no alternatives that don't cause greenhouse gas emissions. We then need to electrify all uses of energy across all sectors, but we will only have half the amount of electricity we'd like to have. That is a true statement both for the UK and globally as a framework within which we want to start thinking about formulating a zero emissions plan. If you want to do it by 2030, which is what you are committed to, it's the same story, except that we should plan to use a quarter of the amount of electricity that we would otherwise like to have, which is why I think it's really, really challenging for you to get there in that time span. So an outline plan for zero emissions cathedrals. For the things that you control directly, only use electric surface vehicles, so no flying whatsoever. There are no electric ships in operation at the moment and no non-emitting fuels for ships either. Switch all heating to electric heat pumps, but use only a quarter of the amount of energy as you would be using to come up with today's level of heat, a half if you wait to 2050. Stop using cement or new steel and reduce all large material consumption to a quarter or a half, depending on your date, and don't eat beef, lamb, or dairy products. Those are the things that you control. What you influence are, of course, the other things like the mix of electricity generation, the wider emissions of agriculture, and the national provision of infrastructure. You have a voice which you could be exercising to bring that about. So far, I've really talked about the Church of England's pledge and the government's pledge. And I now want to move on to the two biggest challenges that you face specifically in cathedrals, which is staying warm and keeping the building up without any cement. So, staying warm. You will not be surprised that the fundamental understanding of staying warm in a cathedral is that heat rises. This graph on the left shows air temperature on the x-axis on a cold day in a building that is 8 meters tall, relatively small by the standards of the lovely building that we're in. Before the heating was on, the temperature was between 1 and 2 degrees. When the temperature was turned on, it generated the profile of the red line. You can see that that means that at my height, the temperature has reached around about 8 degrees. I'm standing on a platform actually, so I might just be able to get to 8.5. Up there, the temperature is about 20 degrees. This is on a cold day in winter because heat rises. And in exact inverse to that, the relative humidity, which has remained sensible at the level that we're sitting, has dropped in order to create a very much drier atmosphere due to the influence of the heat drying out the air. So, can we heat the whole vault using different means? Well, there are 4 forms of heating supply that are used in cathedrals at the moment. Point sources, especially the Gurney stoves in Ely and Peterborough, hot water radiators, which is the most common, underfloor heating, and ducted air. So I've tried to summarize a complicated story on there, and under the huge time pressure I'm under, it's difficult to go into every detail about that. But roughly speaking, the conservators would most like underfloor heating from this. It's the one that's best for the preservation of the building fabric and the artifacts within it. However, it's, as you know, very difficult to install, and depending how it's done, it has a high electricity requirement. Ducted air is the one that is most efficient for electricity, but least attractive to conservators because it creates a very sharp gradient in relative to humidity. And given the budget of electricity that you can access, obviously here it sounds like you've already done that. So terrific, we need to gain all the experience we can, but as a whole, as a country, we don't have enough non-emitting electricity for all of us to do that. And we've got to be careful about taking an action which in effect deprives others of access to the resources that they need to get to zero emissions. The conclusion is you cannot heat the vault of the cathedral. We have not got the budget of energy available to do that. So therefore we need to think about keeping people warm. So we did a study and found a representative member of the Church of England sitting in a cold cathedral as the point of our study. Now the temperature is very low, and you can see that this member of the congregation has already dressed warmly. And the options that we have are to apply convected warmed air through a fan, but the Conservatives don't want us to do that. So we're going to have to take that one out. We could add further clothing. In particular, this member of the congregation was short of insulation on the top. And I've been carrying out that experiment in Ely Cathedral over the winter, and it makes a huge difference. Wearing a woolly hat going to Ely makes it a very much more comfortable experience. We could issue blankets as people arrive, as happens in outdoor cafes all around the world, and if we were generous, we could make an electric heated blanket. We could add radiant heating. I've got a sort of cafe-style radiant heater, but those of you who've been looking at this will know that there are very discreet black panels that you can put on the back of the pew in front of you to create a very localized source only for where the people actually are. Or, of course, we could add heat generation. Sitting still in the cathedral is the worst possible way of keeping warm, and adding more movement is a very good thing. I'm not quite sure about the church positioning, the doctrine that's led to this movement. Charismatic, yes. So we have done a study on this just to give you a few figures as to how this might up to stay warm in a cathedral when the cathedral itself is unheated. The red bars here are things that cause you to gain energy, and the blue are your losses. The left cluster is when the nave is at 5 degrees Celsius, and the right hand when the nave is at 15, which is still lower than the temperature for a sitting person to be comfortable for a long time. So the beginning is to say that at 5 degrees in the nave unheated, if we add more clothing, so that's now long johns and trousers, a thick sweater, a jacket and a parka and a hat, then that's the maximum clothing we can get onto a mobile person inside the cathedral. Then with an electric blanket, they could be warm at that temperature with no heating. We could also do it with a radiant heater, or if we took the blanket away, then we'd have to add more radiant heat. It seems to me it's not crazy to give people a blanket because we're used to that when we come to outdoor cafes. If they were wearing less clothing, then we need to add more heat to them. But the next one, the last one in the first cluster, is just to show you how effective it is to be walking rather than sitting. And this is not my domain, but whether there is an opportunity for more movement as part of the service to stop people sitting for long periods of time, it's hugely effective. You can see it's doubled the heat generation from within the body, and we all know this from our own experience. And so a little bit different for the warmer day. The evidence from the conservators is that the artifacts want to avoid changes in relative humidity. Wood cracks when the relative humidity gets to less than 20%, and it was very close in that example I gave at the beginning. There can also be problems with condensation when there's too much heat, making it too moist at the top. But with the organ, it's not keeping the organ as itself warm. It's actually the pitch of the organ changes as the temperature through the pipes drops. So if you preheat the air going through the pipes, you can maintain pitch without needing to keep the whole nave warm in order to keep the organ in tune. So an outline plan for staying warm in a zero emissions cathedral, which is what you're committed to. There won't be enough electricity available for all of you to heat all the vaults of all churches. People wear warm clothing to arrive, so you should encourage them to keep it on and possibly give them more as they arrive, blankets or whatever. More movement, local radiant heaters in the pews or wherever it is, and create warm zones for the elderly. Whether it's in a low ceiling in one of the side chapels, if you could have a lower ceiling to contain heat so it doesn't rise up to the top, or by other means. So our conclusion is that you can do it, but it's not what the politicians are thinking of when they're thinking of net zero. It isn't invisible. It's not the end of the world, but it does involve participation with the people who are taking part in the service. And I think that's why it's so unlikely that I feel you're going to get there by 2030, because you haven't started having that conversation. And in the cathedrals, it's easy, but in the parish churches with only small numbers of elderly people struggling to keep the door open, this is a tough conversation to have, and it takes time and care to have it. So that was heating. Let's now talk about keeping the building up. Same, I want to start with fundamental tuition. This is Engineering 101. You probably know it all already. But as you all should know, when you're making cement, you cause emissions for two reasons. One is from burning fuel, that's the red section, and the other is from the chemistry of converting limestone into cement. That's the blue band there. The architects who look after cathedrals, when we talk to them about this problem, immediately say, oh, don't worry about us. We use lime mortar, and that's good for the environment. Well, as you can see, actually making lime mortar releases more process emissions. The energy emissions are lower because the process occurs at a lower temperature. And there are two different forms of lime that we'll come on to. The point about this is that even if you electrified all of the heat, which is difficult and nobody in the world has yet done it, but it's an interesting topic, if you electrified the 1500 degrees temperature at which cement is made, you would only cover half the emissions. You've still got the process emissions, and we've got no means to deal with that as we stand. Again, the reason that the architects like to defend lime mortar is with the belief that the mortar reabsorbs the carbon that was emitted while making it over time. Well, if you think about it, the only emissions it can reabsorb are the process emissions, not the fuel ones, and of course it doesn't get it all back. It gets about 70% back over time. If it's a thin layer, like a lime wash used as a plaster, then plausibly it could reabsorb about 70% of the emissions from the process chemistry over a 10-year period. If it's thicker, then it isn't going to be able to do that. So I think for a conservation point of view, you can say that a lime wash, a thin layer of lime, you could justify as being pretty close to net zero, provided you made it in an electrical process, although there aren't any available at the moment. So with zero emissions, the key thing to take away is that there can be no Portland cement. The strong cement that is the basis of concrete, that of all conventional mortar, of all new build projects in the commercial world, is illegal under UK law in 2050, and for the sake of the climate, we have to rule it out. It's the hardest problem in the whole book of things that we're doing about climate change. So that begs the question, where do we use cement in cathedrals? And again, if you talk to the architects, they say, oh, we don't use Portland cement because we're using lime mortar all the time. We found it really hard to get these numbers. The architects deflected us to the conservators, and the conservators were already pressed, and it was hard to get access. But very generously, the archivist in Ely gave us full access to the archives. So we looked back 100 years at all the building projects in Ely. And you can see here, on the left is the materials by volume, and on the right their emissions. Above is what their function was, and the bottom is what their material was. Despite the architect's belief, the dominant material is concrete, and it's concrete used for foundations, for new structure, and cement used to bond bricks and stones together. And in Ely, this is almost entirely dominated by the build project that created the processional way, the new connection between the nave and the Lady Chapel. And that's where these big building impacts occur, when you add something to the building. Maintaining the surface is all right, but refilling the mortar, any kind of new building, you haven't got the material to do it at the moment. However, as you all should know, had you done first-year engineering, as you probably now are wishing you had, cement is a material which is very strong in compression, but very weak in tension. And you know that because if you take bricks from your house after you've been having a building project done, you can separate the bricks and the mortar relatively easily. What you can't do is to crush the mortar by squashing it. So Annabelle has spent a lot of the year trying to look at what it would be like to build new build in the cement, in the cathedral, with no cement at all. And our representative structure here is a very simple arch. We found a stonemason who was able to do a bit of cutting for us for a very discounted price. And here we've got three arches, one filled with conventional lime mortar, one where we've got no interface material whatsoever. We've just stacked the stones next to each other. And one where instead of mortar, we've put a layer of cork. Stone is quite rough when you cut it, so the only function of the cork is to smooth the layer between the two rough layers of stone. The experiments didn't work as well as Annabelle wanted due to some problems that she had not foreseen, but roughly speaking, these three structures have the same strength, that we don't even need mortar in building structures. We use it largely to cope with badly cut stone. And we could imagine new build with stone, which is potentially a low emissions material if it's cut electrically and transported electrically, and we could then assemble structures just by balancing the stones together and ensuring it was loaded so it was only ever in compression. However, the overall story about maintaining cathedrals without cement is don't build. And that's becoming the watchword for all construction companies that are interested in zero carbon. The number one strategy is don't build, but adapt what you've got. We could do some new building with stone masonry without cement, and we know that there are potentially some other materials we could use for the substructures, whether it's rubble or rammed earth or stainless steel screw piles. There could be some other alternative materials, recycled steel or timber, but there's not as much as we'd like to have, and we have to use them with great care to come up with a real zero emission structure. There are very few, because of course one of the lobbies in the space is the timber industry, who are giving misleading statistics about timber. Remember how long it takes the tree to grow. That's the period over which it is absorbing emissions. So with maintenance, I think we can envisage electrically produced air-lime mortar that reabsorbs its process chemistry during the life or over the time that you have within which you want to be zero, but there isn't any yet made with electricity. So let me try and sum it up by thinking about what you mean by leadership. You voted as a body to make a commitment to 2030 net zero emissions without knowing what you were talking about. Actually, that was not a joke. At the moment that you took the vote, none of you had a plan for delivering it. You knew not what you were voting for. That is the same for every other organisation that has made proclamations about net zero, whether it's an airline, a Cambridge college, a school, Extinction Rebellion. They don't know what they're talking about, and that's become the major barrier to change. So I wonder if it's time to rethink that. It's trying to rethink the commitment to take a leadership role, but to do it in a way that you actually can deliver on. If you're going to make the commitment, you can't argue about scope. The scope has to embrace anything caused by your spending and also elements of things that give you income. Within the university, net zero must mean, well, real zero because there are no negatives, zero emissions must mean not having international students who fly. You can't take fees off people if they have to emit in order to be able to come and receive the education. There will be examples of that within your world as well. I think it's going to be very difficult to install alternative technologies over the next 8 years. And I don't think you've had the conversations with the congregations required for abrupt energy austerity, which is the only thing that would credibly deliver on the commitment that you've made. So an alternative, if you imagine the emissions to the atmosphere over, no, they've all gone. If the blue line represents a linear journey to zero emissions by 2050, what actually matters is the total that you emit to the atmosphere. It's the area under the curve that matters rather than the value at any year, because the emissions that you release now are going to stay there for 100 years anyway. So it's the total that you emit that matters. And the orange line emits the same total over the same period to 2050, and it's equal to a cut of 6% year on year in your emissions. And I think you could do that. I think you could make a pledge to really commit to making a real 6% year-on-year cut. And that would be a headline, world-changing delivery that would change everybody's understanding of what real zero emissions actually means. So it's a different form of commitment. I'd be very glad to engage with a discussion on that if it was useful to you. To develop an action plan for understanding what those 6% cuts are, I've put here a pie chart of the UK's emissions. It's too much detail for now and you desperately need tea, so download it if you're interested. But what I've tried to show is what we buy that causes the emissions. The average person in the UK buys 600 litres of fuel per car per year. We, on average, use 10 hours of economy flight per year. So translating that into a 6% cut year on year now is tangible. You know what you're committing to, and you can flex it according to the priorities of what you're spending now. I think that is more achievable. You could start making the easy commitments now, but make sure you always had a portfolio of others so that you're preparing for next year and you're building the consensus within the congregation, taking the investments, getting ready for those decisions ahead of now, and building up to the difficult ones for the moments that they come up. Here are a few examples of what that might mean. A 6% cut might mean just having veggie meals for 3 weeks per year in whatever context we're talking about. Switching from car to rail for one journey every 15 that you would currently use the car. Turning the thermostat down by about a half a degree, that's around about 6% of the heating bill. Switching from petrol, diesel to electric cars, and so on. We can break this down into much more bite-sized, achievable commitments once we've thought about how the numbers add up and once we've got an idea of scale. So, exactly on time for tea, with no overrun, what I have said is that I don't think the UK's policy is credible because we haven't got the resources to deliver on it. I don't think that you're going to deliver on it because you can't access or living with the small amount of energy you could be used is just too tough. The two hardest problems I've looked at and shown you that I think there are solutions to that, although the conservation one is admittedly difficult. And I think the more credible plan is 6% year on year, rather than this drop-dead date, which I think you're not going to be able to deliver. It would be fantastic if you did, but maybe it would be time for a mea culpa now to come up with a plan that you really can defend. Thanks very much. It's time for tea.